So thanks, Renata. I'm delighted to be here today and present a little bit of ways in which we could support the initiative that you're discussing. I think we're late, so I'll be very brief, and perhaps our input is going to be best during the discussion session as we try to find out ways in which we could actually help you. I'll start with a high-level description of our mission. One, as you might expect, is fairly obvious. We have to operate, manage, maintain, deploy high-performance computing resources, particularly for the University of Minnesota research community. We have to support their research by providing the hardware that's appropriate to it. A second mission, we are not a national supercomputing facility, and therefore we are more tightly coupled to the academic part of the university. And our mission there, as it says, is we have to help users accelerate the pace of discovery. That is, how they develop and maintain codes, how they port their software infrastructure, how they parallelize their codes, how they build their environments, and make sure they make this efficiently and as quickly as possible so as to conduct their research in a timely manner. We not only help develop and maintain codes, but we also provide direct consulting expertise in a range of areas that include science, engineering, and the life sciences. Some of them are generic, and some of them are discipline-specific. I'll be brief, as I said, but basically on hardware, as you may imagine, we have large resources, and I'll give you a rundown of what we have a little later. We not only have our own resources, but we help researchers collocate their own resources. We do have data centers, a data center on campus, and as you well know, when you buy a cluster these days, it's not so easy to manage, operate, and house, and we provide collocation services. And of course, we also operate a range of specialized devices and services, for example, high-end visualization. That's on the hardware side of things. On the software part of the equation, we pay for licenses of a range of commercial software that impacts a wide range of our community. Of course, we also maintain open source software. We do provide tutorials, so we not only buy the licenses and we maintain them, but we also help the PI students and postdocs use them. We provide those services. And of course, we support, to the extent that we can, locally developed infrastructure in terms of software and frameworks. User support is the third part of the equation. We help develop applications, the typical parallelization needs, profiling, benchmarking of codes. That comes under both complex application development for you. It has a different angle and perspective and tone for the life sciences. The parallelization part, of course, would feed more into the HPC programming support. And then this may impact your community as you develop collaborative tools, but it's certainly an issue with the life sciences community. We help with a collaborative infrastructure in the form of supporting grid efforts, portals, distributed databases, and so on. We also do a bit of that. This is perhaps what matters to you the most, at least at a basic level. What core resources do we have? We have three major large systems. We have smaller ones. The largest one is called Itasca. It's a canonical commodity cluster that has 8,800 cores, about 25 terabytes of RAM, and it has fast interconnects. It uses an InfiniBand fabric at quad data rate speeds. This is a fairly powerful machine, and in aggregate, it has a performance of 74 teraflops. So this is our flagship core resource at the moment. It's almost a year old, and we're getting good usage out of it. Later this year, we are going to deploy, largely in part thanks to the community that's related to this event, and certainly driven by researchers at the university, we're going to develop a shared memory machine, the first one being mostly a distributed memory machine. It's called Coronis. It's a Silicon Graphics ultraviolet server. It will have 11,000 cores, the same, a slightly different version of an Intel chip.
Does that mean you can't see the machine? That's for special class.
You need 4-dimensional glasses. This machine is rated at 11 teraflops. The third, which has been around now for almost 3 years, Calhoun. It's also a large memory silicon graphics machine. It has 2,000 cores. It's an older generation of an Intel Xeon chip, and it has 4 terabytes of RAM. This machine was intended initially for large memory jobs. Coron is intended for the communities that need large shared memory applications. And the top one is meant for people that can use distributed processors and distributed memory. Storage, we have a total of about 1.8 petabytes of storage on the floor in various configurations. It's a quite sizable amount of storage. And networking, how to get the results out to your building and out to other institutions that are not on campus. We have two 10 gigabit per second link, one which is dedicated to our campus core, and one that goes to the relevant regional high-performance network. I will not get into those, as I promised I'd be brief, but again, to reiterate, we have compute-intensive research, perhaps what you're addressing in this workshop today. We have data-intensive research as well, people that do not necessarily use cycles, but have large storage needs, data mining, and access of that data in a timely manner. We have analytics-intensive research, and then we also support a fair amount of collaborative research. Renata asked me to provide you with a few numbers, and this would be in the compute-intensive research part, and I'll basically skip the other three. What you see at the top is our current usage. We have about 450 PIs. I think it's more close to 500, but anyway, somewhere between 450 to 500 PIs, each of whom, of course, has students and postdocs, so that's our user base at the university. We serve 11 different colleges of the university. And the distribution of cycles, this is one of the many measures that you can actually look into how we provide resources. These are compute cycles. You can see they're basically dominated by engineering and science with a small component that goes to the medical school. Of course, they're huge users of storage, and they're also huge users of tools, grid tools, and portals, websites, and so on. But as you may expect from their disciplines, at the moment, they are not huge users of cycles. At the moment, we have 111 million core hours available every year for users. So it's a significant resource. I wouldn't say it's full, but it's getting there. And therefore, it's a non-trivial resource. Cost. I chose to show you the cost in dollars per core hour. So each of the cores, each of the processing units per hour. And at the last entry, I listed the price of Amazon. Not that I want to emphasize the competition with them, but as a reference point. And we cannot. It's an unfair competition because, of course, we get subsidized buildings, we get subsidized all kinds of things, and therefore we cannot compete with Amazon. I don't think Amazon is supported by the DOE as the light sources are, but maybe they are. I don't know that. Anyway, but it's to give you a sense of the cost, the true cost of an operation like this. Hardware these days, assuming that the machine is going to be around for about 3 years, so you amortize or depreciate in 3 years, it's about 2 cents per core hour. That's what it costs. Operation means the cost of electricity plus the cost of cooling, energy, infrastructure losses, electrical losses. For our machine, which is about 400 and some kilowatts, and assuming a certain performance of the data center, which is not optimal, it would be about 0.8 of a cent per core hour. Management, these would be humans running the machine, making sure it's available, performing backups of storage when needed, and so on. That's another 7 cents. So in total, it's about 4 cents a core hour. That's what it costs the university, including electricity and management, to run this facility. As I said, it is not to show you a comparison with Amazon because, again, we get subsidized buildings, we get subsidized fire protection, we get subsidized police, we get subsidized lots of things. But that's a bit of the order of magnitude of the cost. I will not get into this. We have other types of research which basically center around database management, database accessibility, portals, and so on. That's now mostly, at least yet, geared to the life sciences, but I imagine that's something that in your group may want to consider in the future as well, as the quantity of data to manage also grows. How do we support you? This is a bit of a summary, and maybe I'll quit. We will provide to this effort and to any other user on campus HPC services, directly helping you debug your code, develop parallel versions of it, and so forth, profiling, optimizing, etc. We will run tutorials for your students and postdocs in addition to working with them. So these are direct HPC services. We may provide another layer of complexity if you need what I call framework development. That would mean not only you produce data that you put in graphs that you show in talks like today, but you also have to make the data widely available and usable to the community, and we're also helping you build those types of resources, data management, warehousing the data, data manipulation tools, data mining services if the data requires it, portal development so researchers here and elsewhere can access data, grid services, so if that's an opportunity that you may want to leverage because you have many sites and you would like to have resources running at various sites, we can also get those running for you. And of course, visualizing and image processing, two slightly different aspects of analyzing data. Direct user services, we also get a little closer to the user, which is not deal with the code, but we have a little bit of discipline-specific consulting. We do have a fair number of PhDs that are trained in various disciplines that can actually help you, or not you directly, but your postdocs and students with their development needs. And we like to think that having a little bit of knowledge of the area is actually going to make us more efficient in providing those services. That includes technical support and training, not only for your code, but also if you choose to use commercial or open source software. And of course, we also integrate with many of you in proposal development. We like to that you use as a resource in leveraging these resources in your proposals, and vice versa. We also like to leverage your scientific interest and expertise in developing proposal for hardware. So that's another area in which we like to spend some time. And I think I'll just quit here, see if we can catch up a little bit of time. I'll be around for the discussion, and I'm sure lots of questions will arise related to this, and I'll be here to answer them. Thanks, Renata, for having me here. Being recorded. Go ahead.
The first is how do you or individual groups handle backups? And then the second is do individual groups get dedicated nodes, or does everything go into the general queue?
Two questions. The backups, I think, well, you help me with this. I don't think we back up exactly everything. We probably back up only the relevant home partitions of each user. I don't think we back up the entire data set. I don't think we'll ever do that. In terms of dedicated services, at the moment we don't, but we will, I think. So you may want to specialize hardware configurations, you may have time constraints, and those will service on a fee basis. At the moment, we do have fee-based storage. There are groups that are purchasing their own storage because they have more needs, so we maintain it and we integrate it with the rest of the storage, but we charge the users. The rest is free at the moment. Are you listening to me?
Did I understand correctly that your supercomputer center belongs to this university?
The question is if the supercomputing center belongs to the university. Yes.
And how much does the university pay to have such a center?
A lot of money.
Well, I'm asking for a very practical reason. I want to come back to my university.
I will not answer the question. I don't think. think of it as ALS and the users buying beam lines, I guess. Except our beams are electrons and the lines are not very straight.
More questions? Okay, you will participate in this